This is a lesson on verifying trig identities, part 1, the introduction. There are some different tools that you are going to use to verify. It's kind of like a proof in geometry. You want to prove that this equation is in fact equal to each other. So the most popular way is to always start with one side of the equation and work with that same side all the way through. So one side of the equation. Now the next things are some suggestions. Here are some things you might need to do. Sometimes you might need to factor an expression. Sometimes you might need to add fractions together. Sometimes you might need to square a binomial. So foiling out a binomial. Or finding a monomial denominator. In the green here, you really have to be comfortable with your fundamental identities, especially the Pythagorean, and know the different forms of those Pythagorean identities. So when you're doing your homework, when you're doing your assignments, and you're proving the verification of the trig identities, have that formula sheet out on your desk. The fundamental identities are key. Number 4 in the black, sometimes it's good to convert the entire left side or right side of the equation to a sine-cosine form. You usually want to start with a more difficult side, using some of your identities to convert it to getting it to the other side. And then step 6 is to split up a fraction up. All right, so we're going to just take this next problem nice and slow. You may want to pause on this video so you can kind of get the grasp of it. I put all the steps here for you. I identify the identities, etc. So here's what we give you. We want you to verify that this equation is true. They equal each other. So right now they don't look like they equal each other. So we're going to start with the left-hand side. The left-hand side is the more difficult, has more stuff going on. And what we're going to do is try to replace this left-hand side with some of our identities and move things around. Some of those tools that we learned in the last slide. So we're working the blue side. And we want it to get to look like the right side, the sine squared of theta. So step 1, work with one side and one side only. So I've chosen the left side, the more difficult side. All right, and now I'm just going to take that left-hand side and manipulate it. I'm going to use my fundamental identities sheet, my gold sheet, and see if I can find an identity that I can maybe replace. So if you notice here, I identified one of the Pythagorean identities, secant squared of theta minus 1. So maybe go ahead and look at your identity sheet and see if you can find that. Secant squared of theta minus 1. Can you find it? Does it equal the tangent squared of theta? So again, take your time, look at your identity sheet. Secant squared of theta minus 1 equals tangent squared of theta. Now I have not done anything else with the denominator yet. Again, please make sure you pause if you need to. All right. Now what I did is I just split up this fraction into 2 pieces. So I have this green piece of my tangent squared of theta alone, so it's a little easier to see. And then I took this secant squared of theta, and I'm going to throw a 1 here. So it's 1 over secant squared of theta. I'm breaking the fraction up into 2 pieces. And you'll see what happens next. Now, what I've done is I've replaced this 1 over secant squared of theta with the reciprocal identity. So again, look at your gold sheet. Find the reciprocal identities. 1 over cosecant squared of theta is cosine squared of theta. Now on your formula sheet, they're going to say this instead. The cosine of theta equals 1 over the secant of theta. But that can work for any power. So if you want to say a squared, a cube, a fourth power, it's all true. So the cosine of theta equals 1 over secant. So we can replace it right there. So there's your reciprocal identity. Now let's look at the quotient identity next. So over here, I can look at this tangent squared of theta, and I'm going to convert it to all sines and cosines for the quotient identity. The quotient identity says this: the tangent of theta equals the sine of theta over the cosine of theta. I keep losing my smartboard connection here. Now, if you want to change this to a tangent squared, then this is a sine squared and a cosine squared. So now I can replace it right here. Now I've converted everything to sines and cosines. Do you see something that you can cancel out now? So I just rewrote this, and I can cancel out this cosine squared of theta and this cosine squared of theta. So what I'm left with is just the sine squared of theta. This is my final answer. That's what I wanted. So let's go back up to our problem. We wanted sine squared of theta. So we continuously worked with the left-hand side, rewrote, used our identities so that we showed that that left-hand side does in fact equal sine squared of theta. We've proved it. These problems are going to be a little challenging. You're going to need to work with friends. You're going to need to work with me. Things like that so that you can be comfortable with those identities. Have your formula sheet out. Have that gold sheet out. Have your notes out when you're doing these problems. You will see some more videos on these examples.